The weather has been really hot lately. My workshop also gets weak electricity sometimes, so using big appliances is not always easy. I started wondering if some old parts could help with this heat. To begin, I need to find a few suitable parts. Many DIY ideas start by looking around the storage area. Some old things can still be useful. I start by checking this battery to see if it still has power. The light bulb is not needed for today, so I remove it. I use another alligator clip to check the contact. I touch the clip tips together very briefly. A small spark means it still conducts. I do not hold it there because a short circuit can damage the battery. Now I test a 12-volt brushed DC motor. I connect it to the alligator clips, powered by the battery. If the motor spins smoothly, this important part can still be used. Luckily, this motor still works. I removed it from an old cordless drill. The drill had a mechanical jam, but the motor itself still runs after cleaning. For the next step, I need to mount the motor to two perforated L-shaped metal brackets, but the holes on the brackets do not match the screw positions on the motor. So I need to grind the metal a little to make it fit. Small steps like this should not be rushed. If the motor is mounted off-center, it may vibrate later. I will leave the motor there for now. Here I have a soldering iron, but I will use it in a different way. Let us see if this little trick works. This is the trick. I attach the tip of a utility knife blade to the soldering iron. When the soldering iron heats up, the heat transfers to the blade. That makes it easier to cut thin plastic. What do you think I am going to cut and use it for? Now I need two thin plastic containers. I will not use the whole container. I only need one part of it. It may look ordinary, but many DIY projects begin with small parts like this. After marking the container, I use the heated blade to cut along the line. This method makes thin plastic easier to cut, but it should be done slowly and in a well-ventilated place because hot plastic can smell unpleasant. Do you think this little trick is useful? As you can see, I will reuse the cut plastic body and the mouth of the container. Now I need to make a hole on the side. This hole is for a short PVC pipe. If the hole is too far off, the pipe will not fit tightly. Once the container mouth is shaped, I attach the PVC pipe to the hole I just made. I use glue to hold it firmly. This part needs to be secure because air will pass through it later. If the joint is loose, the result will not be as good. Now I need to find a larger box for today's project. After looking around the workshop, this foam box from the woodshop still seems useful. On hot days with weak electricity, a box that can hold cold air is worth trying. I work on the lid first. I need to make one large hole and 4 smaller holes. These positions have already been measured to fit the parts I will install. The 2 container mouths with PVC pipes will go into 2 holes on the lid. There is still 1 large round hole and 2 small holes left. Can you guess what parts will go there? In the large round hole, I mount the 12-volt brushed DC motor onto the foam box lid. Later, this motor will hold a fan blade. Then, I wire the motor and protect the joints with heat shrink tubing. After that, I attach the 12-volt battery to the foam box lid with double-sided tape. I also install the 2 container mouths with PVC pipes into 2 holes on the lid. Each part is slowly finding its own place. In the 2 remaining round holes, I install 2 flexible sink drain hoses and connect them to the cut container mouths. Now the air paths are in place. At this point, the main structure is almost finished. The next step is the part that makes this project worth watching. Now I pour a bag of ice cubes into the foam box. This ice will be the main cold source. I add a little water to help the cold spread through the box faster. I keep the water away from the electrical parts. Now I close the foam box lid and get ready to connect the motor to the battery. By this point, you may already guess where this project is going, but the real result must be tested. DIY is like that. Do not believe too quickly, but do not doubt too early either. I use an electronic thermometer to check the airflow temperature. This gives a clearer result than just feeling it by hand. After a few seconds, the temperature of the outgoing airflow drops from 24.3 degrees to 19.6 degrees. The motor only pushes air through the ice inside the foam box. Pretty interesting, right? If you like this idea, leave a comment, hit like, share, and subscribe to the channel for the next projects.